In this video, my math peeps, what we're going to be doing is finding out how to solve one-step inequalities involving addition or subtraction. The main idea here is that we're really not changing anything from when we solve equations involving addition or subtraction. Let's dive right into it. We are going to be graphing our solutions because they're inequalities after all. So we've got x minus 7 is less than or equal to 9. We want to find all the x values so that when we evaluate numbers in for x, we get a total value on the left that is less than or equal to 9. So there's lots of solutions to that, right? I could just pick one off the top of my head. 4. 4 minus 7 is negative 3, and negative 3 is less than or equal to 9. But see, here's the thing. We need all the solutions. So we're going to solve this. How do we undo minus 7? We add 7. So we're going to solve this just like a one-step equation. So we're going to add 7 to both sides. When I do that, I undo minus 7, and I'm left with x is less than or equal to 9 plus 7 is 16. And that's our solution. So that means all x values less than or equal to 16 will work here, which makes sense. If I plug in 16 minus 7, I get 9. So that's the equal to 9. And any number less than 16, pick one, 10. 10 minus 7 is 3, which is less than or equal to 9. So any number less than that boundary will give us a number less than or equal to 9 on the left side. So here we go. I've got my number line, which you're going to draw a pretty small one there. I'll put the number 0 there, and then the number 16 right here. If we're less than or equal to 16, we want to include the 16. So we're going to do a closed circle and then shade in all the numbers to the left of 16 because that would be all the numbers less than it or including it. On to letter B. U plus 10 is greater than 4. How do we undo plus 10? We subtract 10. So we're going to subtract 10 from both sides. And then we're left with just plain old u, because this cancels out, is greater than 4 minus 10, which is negative 6. So now we've got that all numbers greater than negative 6, when added to 10, will give me a number greater than 4. And sure enough, if I plug in negative 6 plus 10, that is 4. So any number more than that will give me a number more than 4. Okay, let's do a number line now just to show all of our solutions. So here's my number line. I'll put the number 0 right here. Our boundary is at negative 6. We want numbers more than negative 6, so don't include it. So we're going to be like, hands off, bro. Don't include that negative 6. So the symbol for that is an open circle. And then all the numbers to the right of negative 6. And then we'll be in great shape. That's it. Those are all our solutions. On to letter C. So let's check this one out. We've got 16 is, less than or equal to m minus 12. So what is that all about? Well, the main idea here is I kind of switch things up. I put the inequality in such a way that you've got a variable on the right-hand side. A lot of people are uncomfortable with this and prefer switching everything up, having the variable on the left. So there's two ways of doing this problem. I'll show you both ways. I can rewrite this problem so m minus 12 is greater than or equal to 16. So I'm not switching up the truth of this statement. I'm merely taking the m minus 12 and moving it here, making sure it still states that we're greater than or equal to 16. As it read right to left, it should read the same way left to right. Now I have the same kind of problem. So I undo minus 12 by adding 12 to both sides. And then I'm left with m is greater than or equal to 16 and 12 is 28. Very cool. So we'll graph that out. 0, I'll put my boundary of 28. And we have all numbers more than or equal to 28. So we are going to include 28. So I'll include that. And then highlight all the numbers more than or equal to, which makes sense, right? If I plug in a number higher than 28 minus 12, I will get a number more than or equal to 16. Now, other people are okay solving this problem as is. Just to show you real quickly that there is nothing wrong with keeping the orientation of the problem, the way that it's facing the same. Undo minus 12 by adding 12 to both sides. And you'll be left with 28 is less than or equal to m. Or read the other way, m is greater than or equal to 28. So I prefer getting the variable back to the left side. I usually teach it that way, but nothing wrong with showing it that second way. Last but not least, a little bonus type problem. A lot of people don't like when their variable is second. No issues there. Remember, this is just adding 3, adding a positive 3. So how do we undo that? we subtract 3 from both sides. So I just wanted to show this in case you encounter a problem that is set up this way, it's no sweat. Minus 3 from 3 is 0, we're left with a positive f. Is less than negative 10 minus 3 is negative 13. And then of course we're going to graph that. Why wouldn't we? Our boundary is at negative 13. I'll put that right here. We're saying we're less than negative 13, so we don't include it, and we take all numbers to the left of 13, so we shade all those numbers in. That's it in terms of the process and seeing how this is a lot like one-step equations. Bear with me here for an extra minute. I'm going to go over why, when you solve these problems, you can just pretend like they're one-step equations. Here's the main idea. When you're solving out any inequality, so let's take, I'll just do x minus some number is greater than another number. So we'll call that number sub 2 and number sub 1, right? So two different numbers. So if I add number sub 1 to number sub 2, it doesn't change the truth of the inequality. And you might be like, why? Well, that's what I want to show you. X minus some number is, after all, some bigger number. So we'll call that A is greater than some number B. So I'm saying this is the normal setup, but in general, you're saying we've got one big quantity, a value, more than another. Well, let's say that you add a number to both sides, right? So now I'm going to replace A and B with adding 1 to both sides. Well, if I add 1 to a number that was already more than this number, it's still more than B by the same amount, right? So let's do this with numbers. Let's say I have 4 is greater than 2. If I add 1 to both sides, I get 5 is greater than 3. And if I subtract 1 from both sides, I would get 3 is greater than 1. The point being is the inequality is maintained as true no matter how much I add or subtract the same amount to both sides. So this works much like why one-step equations with addition and subtraction works. The equality and the inequality stays true as long as you do the same addition or subtraction to both sides.